Okay, so in this lecture we further continue our discussion on distance relays. So let us start with one example on distance relay. So the example is given here. The relay R is a Moore relay with characteristic angle 65 degree. So here single line diagram of a portion of power system is given. The several 3 transmission lines are connected. One is L1 between bus 1 and 2, another is L2 and L3 from bus 3. So the relay R is located between at bus 1. So it is a distance relay having more characteristic with characteristic angle 65 degree. The 3 zone settings of distance relay R is given. So K1, K2 and K3, these 3 values are given, and we need to determine the zone 1 reach of relay R from bus 1. So what is the reach of relay R from bus 1 for line N1, that we need to determine. The second B case, we need to determine the zone 2 reach of same relay, that is R for from this bus 2 or bus 3, because both are same, only the difference is the voltage level. So for zone 2 reach we need to find out it from the for line L2 in kilometer, and same way for part C we need to determine the zone 3 reach of relay R again from the same bus for line L2, and that is also in kilometers. So to solve this example, let us start with the first part, that is the what is the zone 1 reach of this relay. So let us start with zone 1 reach of relay R with value given, that is K1, K2, K3 that is given, and theta, that is characteristic angle, it is also given. So let us start with first part, that is the A part. So zone 1 setting, of relay R. So the value of K1 that is given for this, K1 is the zone 1 setting and its value that is given as the 5.2. So the value of K1 that is given as 5.2, the value of K2 that is given as 17.32, and the value of K3 that is given, that is as 22.72. The characteristic angle theta that is also given, that is 65 degree, and the CT ratio is also given. So CT ratio is 1000/1 ampere, and the PT ratio that is also given, that is given as 220 kV by 110 volt. So this values are already given, and we need, based on this value we need to find out the first zone reach of relay R for line L1. So we need to find out for line L1. So let us determine what is the impedance of line L1, let us call it ZL1. So the value of line L1 that is given as, its impedance is given, which is 0.0316 plus j 0.1265, and the length of line L1 that is also given, which is 95 kilometer long. So with this value let us find out the whole impedance of transmission line. So that is nothing but 0.0316 plus j 0.1265 into line length, that is 95 kilometer. So the value, if you solve it, you will get the value, that is 3 plus j12, this is in ohm. So if I convert this value in polar form, then it is 12.37 at an angle 75.96 degree, this is in ohm. So the value of ZL1 we have already calculated. Now as the value of K1 is given, that is 5.2, so we can find out, we know that K1 that is equal to Z1 secondary divided by cos of theta minus phi. So this equation we know. So Z1 secondary that is equal to K1 into cos of theta minus phi. So K1 is given as 5.2 ohm into cos of theta is given as 65 degree characteristic angle minus phi. Now this phi is nothing but this value given of ZL1 75.96 degree. So if I solve this value, we have Z1 secondary, that is equal to, the value comes out to be 5.1052 ohm. So you can easily find out the value of Z1 secondary. Now we know that the Z secondary, that is equal to the Z primary into CT ratio divided by PT ratio. This equation we know, we have already discussed this. So using this equation we know the secondary part, so we can easily find out the primary part. So Z1 primary, that is equal to Z1 secondary into the reverse PT ratio divided by CT ratio. So that is Z1 secondary, that is 5.1052 into PT ratio, that is 220 kV by 110 volt. So 220 into 10 raised to 3 divided by 110 volt into CT ratio, that is 1000/1 ampere. So if I solve this, we have the Z1 primary, that is equal to 10.2103 ohm. So we have already calculated the primary part. So now what we need to find out? We need to find out the, if I just go to the figure, we need to find out what is the zone 1 reach of relay R. So as we have already discussed, the zone 1 reach of relay R, that is normally 80 to 90% from bus 1, right. So we need to find out up to what this point in terms of kilometers the reach of L1. So that we need to find out. So if we need to find out, then what we have to do is, we have already calculated the Z1 primary. So zone 1 reach of relay R from bus 1. So that is given by your Z1 primary divided by ZL1 in per kilometer value. So we know that Z1 primary, that is equal to 10.2103, we have already calculated, and divide by ZL1 per kilometer, that is this value. So that is 0.0316 plus J 0.1265. So if I solve this, then the zone 1 reach of relay R from bus 1, that is equal to, the value comes out to be 78.54 kilometer. So you can see that this value, that is in this value is given, and this value, that is in per kilometer basis. So this is also in ohm, and this value is in ohm per kilometer. So you will get kilometer. So first part, that is completed, that what is the zone 1 reach of relay R in terms of kilometers from bus 1. So that we have completed. So you can see that we have the this value, this length covered by relay R in first zone, that is 78.52 kilometer. So that we have calculated. Now let us consider the second part, that is what is the zone 2 reach of relay R from bus 2 for line L2. So let us solve this. So the second part, we need to find out the zone 2 reach of relay R, and that is from bus 2 or bus 3, right, both are same, because both buses are in same substation. So let us find out this value. So zone 2, if I consider the figure, then the zone 2 of relay R, that covers the entire length of line L1 plus the reactance of this transformer. So let us find out what is the total impedance of line L1 plus the reactance of the transformer. So let us find out what is the value. So that covers the whole line length. So that is ZL1 entire line length, plus the transformer reactance, let us call it ZT. So, this value, the ZL1 total, that is we have already calculated, that value is 3 plus J12 ohm. So, this value is 3 plus J12 plus the transformer reactance. So, here the transformer reactance is given as the 10% and the this line L1 is on 220 kV side. So, MVA value is given, voltage is given. So, we can easily find out the value reactance of this transformer. So, that value is nothing but J 10%. So, 0.1 into the equation is kV square divided by MVA. So, kV, that is 220 kV whole square and MVA value, that is 250. So, we know that when we solve the equation, Z per unit, any value of in per unit, that is given as actual value upon base value. So, here this value which we have calculated, that is the actual value. So, we have multiplied this per unit, that is 10% or 0.1 with base value which is given by this equation, that is kV square upon MVA. So, if you solve this, then that will be 3 plus J12 plus J, this value that comes out to be 19.36 ohm. So, ZL1 plus ZT, that is equal to 3 plus the value comes out to be 31.36 ohm, or if I convert in polar form, then that is 31.5 at an angle 84.53 degree, this is also in ohms. So, this we have calculated. Now, the value of K2 is given. So, the K2 value, that is equal to 17.32. So, K2 is given 17.32. So, we know that K2 is equal to Z2 secondary divided by cos of theta minus phi. So, this equation you can remember that any value of K x, that is equal to Zx divided by cos of theta minus phi, where x stands for 1, 2 and 3, that indicates the zone value, zone setting. If you take first, then it is K1 Z1, if you take second it is K2 Z2, if you take K3 3, then it is K3 Z3. So, you can easily find out 3 zone setting equation using this. So, if I just put the value Z2 secondary, that is equal to K2, that is 17.32 into cos of theta, that is 65 degree minus phi. Phi we have already calculated because of addition of this reactance of transformer, the value of phi changes. So, it is 84.53. So, if you solve this Z2 secondary, that comes out to be 16.32 ohm, right. So, based on this you can easily find out the Z2 primary, which is equal to Z2 secondary into PT ratio divided by CT ratio. So, if I put this value 16.32 into PT ratio, that is 220 into 10 raised to 3 divided by 110 into 1000 by 1. So, the value of Z2 primary, that comes out to be 32.64 ohm, right. So, we have calculated the value of Z2 primary. Now, see, we need to find out the zone 2 reach of relay R from bus 2 or bus 3. So, if I refer what is the zone 2 reach? Zone 2 reach of in second zone of relay R, that starts from here, but after some time delay we need to find out whether for line L2 from this bus up to how much kilometer this reach will enter for line L2. So, this value we need to find out in kilometers. So, for that what we will do? We will take the whole Z2 primary value which we have calculated and we subtract it, from that we subtract the entire impedance of line L1, that is ZL1, plus reactance of the transformer, that is ZT. So, if I just find out the zone 2 reach of relay R from bus 2 or 3, both are same. So, then that will be equal to Z2 primary minus ZL1 plus ZT. So, that we need to subtract, so that we can find out its reach from bus 2 or bus 3, divided by, we need to find out the value. So, if I just put the value, then the value and in denominator we have just we need to find out zone 2 reach from here. This value we have already put in numerator, that is Z2 primary minus ZL1 plus ZT. So, that is here, and in denominator we have to consider the impedance of line L2 on per kilometer basis. So, if I just, this is your ZL2 per kilometer. So, if I put this value here, Z2 primary, you can see it is 32.64 ohm. So, that is 32.64 minus minus ZL1 plus ZT. So, that comes out to be 31.5. So, this is 31.5 divided by ZL2 per kilometer. So, the value of ZL2 per kilometer is 0.04 plus J 0.16, right. So, if you just solve this, you will get the value 6.91 kilometer. So, if I just look at this figure, this value is 6.91 kilometer from this. So, from this bus, from this point, the second zone reach of relay R for line L2, that is only 6.91 kilometers. Now, let us solve for zone 3 reach of relay R. So, now in order to solve the zone 3 reach for relay R, again for same line length, that is L2. So, what we need to do is, we need to consider the entire line length of L1 plus reactance of the transformer, plus we need to connect the whole impedance of line L2, but that we need to refer on 220 kV side where the relay is situated, because line L2 is on 132 kV side, whereas the relay R is situated on 220 kV side. Let us start the third point, that is zone 3 reach of relay R from bus 2 or 3, right. So, for this, let us consider the ZL1 plus ZT, right, plus additionally we need to consider ZL2, that is referred on 220 kV side, right. So, that we need to calculate. So, if I just add ZL1, that is 3 plus J12 plus ZT, that is J 19.36 plus ZL2. So, the value of ZL2, that is 4 plus J 16. So, if you just look at the figure of this, the value of this line impedance for L2, that is given as the 0.0175. So, the value I am writing this ZL2, that is 0.04 plus J 0.16 and its line length, that is 100. So, if I just write down here the value, this value is 0.04 plus J 0.16 and the length of L2, that is 100 kilometer, and same way for L3 if I write down, its value is 0.0175 plus J 0.075. This is the impedance of this line on in ohm per kilometer. This value is in ohm per kilometer and this is also in ohm per kilometer, and the length of L3, that is 75 kilometer, right, and the length of L1, that is also right, that is 95 kilometer, and we have already know its impedance is 0.0316 plus J that is 0.1265. This is in ohm per kilometer, right. So, now one important point, when you consider the zone 3 reach of relay R for line L2, it may possible that in actual field number of lines are emanating from this bus. If there are more than 2 lines or 3 lines, then you have to find out the zone 3 reach of relay R for that line whose line length is highest. So, in this case L2 and L3, the line length of L2 is higher than L3, that is why we have considered L2. If line length of L3 is higher than L2, then we have to consider line L3. So, the value on this side is, if I consider ZL2, so ZL2 value, if you look at the value, that is 0.04 plus 0.j16 into the line length, that is 100. So, it comes out to be 4 plus j16. So, if I write down here, it is 4 plus j16, and this value we need to refer on the 220 kV side. So, it is 220 by 132 whole square. So, this comes out to be 220 by 132 whole square. So, if you solve this, you will get the final value of this, that is 77.1 at an angle 79.46 degree ohm. So, this comes out this value. So, if I need to find out now again zone 3 reach of relay R from bus 2 or 3, right, then what we need to do is, we have the Z3 primary minus ZL1 plus ZT, that is as it is, and divide by, we need to find out for line L2. So, it is ZL2 per kilometer. So, this value Z3 primary we have already calculated 77.1 minus the ZL1 plus ZT, that is the value is how much, okay, just a minute, it is 31.5, but okay, this value is not there, because whatever value you have calculated here, this value is different. Why? Because the K3 is given. So, the value of K3 is given as, what is the value? K3 is 22.72. So, if I use that value 22.72, you can find out from this Z3 secondary, right, using this equation, K2 is equal to Z3 secondary divided by cos of theta minus phi. Phi you need to use, that is this value, and theta is as it is 65. So, K3 is given. So, you can find out Z3 secondary, that comes out to be 22 ohm, and if you find out based on this Z3 primary, then that comes out to be 44 ohm, almost double because of PT ratio and CT ratio. So, the value Z3 primary you need to consider is not this, but that is 44 ohm minus ZL1 plus ZT, that is 31.5 divided by ZL2 per kilometer. So, that value is 0.04 plus j 0.16. So, this value is in ohm per kilometer, this value is in ohm. So, you will get the value in kilometers. So, that comes out to be 75.8 kilometers. So, if I just refer the figure, then the zone 3 reach of this relay R, if I consider from here, then it will go from this point to, you see the length of this line L2 is 100 kilometer. So, this will go from this point the 75.8 kilometers. So, this value is 75.8. So, if I add this two, that is 75.8 zone 3 reach of relay R for line L2 and 6.91 kilometer, that is the zone 2 reach of relay R from bus 3 for line L2, then this value comes out to be 82.71 kilometer. If you add this and this, right, and the total line length of L2 is 100 kilometer. So, out of this the backup provided for line L2, that is 82.71 kilometer. So, entire line L2 is not protected. So, if primary fails for L2, then the some other line will take care, but only up to 82.71 kilometer, not beyond that. So, 100 minus 82.71 kilometer, that is again not protected, means for that section, line length section, the backup is not available from other relays. So, that is the meaning of this. What we have done? We have solved one example. So, when you solved the example of any distance relay, the first equation you need to remember, that is this, that is the Z secondary, that is equal to Z primary into CT ratio oblique PT ratio. And the second equation you need to remember, that is the value of K x, which is equal to Zx divided by cos of theta minus phi. This phi that changes, theta is your characteristic angle, right, which is already given, which depends on what type of characteristic you have used. X stands for that is equal to 1, 2 and 3, that indicates zones, right. So, zones of distance relay. So, it can be first zone, second zone, third zone. So, K1, K2, K3, and phi again that depends on whether if any transformer is involved in that, right. Whenever transformer is involved, then the value of phi again changes. So, that you need to understand, that whenever transformer is connected at any substation and when you add its reactance, then the value of phi always changes. Again the value of phi also changes when you have or when you wish to include the value of RF, that is known as fault resistance. So, whenever you add fault resistance in the any line impedance, then also its value changes. So, how, let us see how the value of phi changes. So, for that we need to understand the one important point. Just take small example. Say if I consider the same value, right, say the ZL1 is 3 plus J12. So, if I consider the same value, right, say the line impedance is 3 plus J12, right, and if I write down in polar form, then its value comes out to be roughly around 12.37 angle 75.96. So, it is 12.37 angle roughly 75.96 ohm. Now, if I just suppose specify that the characteristic, let us say we are utilizing Moh characteristic with characteristic angle theta is equal to 65 degree. Now, if I specify that suppose this characteristic is also able to include or incorporate fault resistance RF, that is equal to, let us say 2 ohm. So, then if for each and every case, whenever I, this is your ZL1. So, whenever I calculate the value, I need to again calculate the value of my primary impedance, right, and whenever I need to include this primary impedance, we need to also consider the value of RF in that. So, for that let us consider the one example. So, suppose the line length is given, one line is connected between two bus, right, and suppose, so let us consider, just I want to just show you what is the impact of RF. So, let us consider the line length is 2 plus J8, right, the relay is located here, that is R, CT ratio is 1000 by 1 and the PT ratio that is given as the value, that is 220 kV by 110 volt. Now, the first zone of this relay R, that is 80% of line length, right. So, this is line length, let us say this is line L1. So, let us say this is L1. So, if I take this value 80% of this, then it comes out to be 2 plus J8. So, that comes out to be the value, that is the 1.6 plus J 6.4, right. This is in ohm. Now, if I say that this relay is capable to include RF is equal to 2 ohm, then this is your Z1 primary, of course, this is primary value because you have calculated it. Now, if I say this relay is capable to include the 2 ohm resistance, then what should I do? I need to find out Z1 dash, which is modified primary, and that is equal to 1.6 plus J 6.4 ohm plus 2 ohm. So, if I calculate earlier case, if I just calculate the value, what is the 2 plus J8 value, then it is 8.246, the angle is 75.96 ohm. So, in earlier case the angle is this, when I add 2 ohm fault resistance, the value comes out to be the 3.6 plus J 6.4. So, if I convert it, you have some magnitude and the angle that comes out to be 60.64. So, you need to consider this Z1 dash primary, because in that case this angle phi reduces. So, here earlier case it was 75.96, now it will be 60.64. So, each and every time if you then you have to add this value in zone 1, zone 2 and zone 3, and then you have to find out modified impedance, right. So, Z1 dash primary, Z2 dash primary, Z3 dash primary, then you can calculate Z1 dash secondary, Z2 dash secondary, Z3 dash secondary, and similarly you can find out K1, K2 and K3, right. So, this is just for knowledge that when any fault resistance is given, then you need to include it in the calculation of impedance. So, we have already considered 2-3 examples on distance relay. So, I stop here and we will continue our discussion on distance relay in the next class. Thank you.